Okay, so this is extra practice for chapter 14. We're gonna work out 1 to 12. So whatever you need help with, fast forward to. 1 and 2, we're finding the unit rate. So 84 miles to 12 days. Unit rate means we want 1 day, okay? So in order to do that, we divide by, 12. Do the same thing to the numerator, divide by 12. 84 divided by 12 is 7. And then anytime we write the unit rate, we write it out, 7 miles per day. That got sloppy, per day. It's the problem with Sharpie, I can't erase. Number 2. 2 and 2/5 kilometers in 3 and 3/4 minute. This looks complicated, but it's really not. Remember, anytime we want the unit rate, we want the second number to be in terms of 1. So not 3 and 3/4 minute, but 1 minute. And any number divided by itself is how we get to 1. So divide by 3 and 3/4 and you'll have it. So this you probably have to work out off to the side. I'll do it right here. 2 and 2/5 divided by 3 and 3/4. Okay, the very first thing we need is improper fractions. So 5 times 2 is 10, plus 2 is 12 over 5. 3 times 4 is 12, plus 3 is 15 over 4. And then to divide fractions, we actually multiply by the inverse. So 15/4 becomes 4/15. I would reduce first by 3. 3 goes into 12 4 times. 3 goes into 15 5 times. Now we can multiply straight across. 4 times 4 is 16. 5 times 5 is 25. Okay, so 2 and 2/5 divided by 3 and 3/4 is 16/25 of a kilometer. And then when we write the unit rate, we take it out of this form and we would write it 16/25 of a kilometer per, remember we use per to mean 1 per minute. So this is how your answer should look. Okay? Number 3. Tell whether the rates, are they rates or ratios? Tell whether the ratios form a proportion. So we just want to know if these ratios, or these fractions, if you will, are equal. We can use cross products, we can reduce, we can find a common denominator. Okay, and this, I always choose to reduce, just a personal preference. So divide these by 6, and I get 1/9. 1/9 is already reduced. These are equal, so we would say yes, they'll form a proportion. Okay, number 4, same idea, new ratios. Number 4, we have 9/12 that we're comparing to 8/72. In this case, maybe you want to find a common denominator. I know that 12 times 6 gets me to 72. So do the same thing up here. 9 times 6 is 54. 8 already has a denominator of 72. These are not equal, so you can say no, they don't form a proportion. You could reduce these also and get ratios that aren't equal, and you would still say no. Okay, number 5. Use a graph to tell whether X and Y are proportional. So here we go. We have a few points we have to graph. here's our X, here's our Y. My X coordinates are 2, 4, 6, 8. So guess what I'm gonna count by? You guessed it, 2s. My Y coordinates are 10, 20, 30, 40. So guess what I'm gonna count by? You guessed it, 10s. As long as I count in equal intervals, it's okay if the X and Y axis are different, okay? So let's plot our points. The first one is 210. The second is 420. The third is 630. And the last one is 840. We always connect. Okay, so how do we know if it's a proportion, or how do we know if X and Y are in a proportional relationship? This is the key right here, okay? Anytime a graph passes through 0, 0, or you can call it the origin, we would say yes, okay? So yes, that graph, I don't know if it said to explain, passes through the origin, okay? If it didn't go through the origin, if it hit the y-axis somewhere up here or somewhere down here, even below 0, it would be no, okay? Number 6. Okay, number 6 is a graphing to tell if X and Y are in a proportional relationship. Let's look at our X coordinates. They go up to 15 and they start with 3. We have to count in equal intervals. So I'm gonna count by, I don't know, 3s. 3, 6, 9, 12, 15. Some of my points I'm gonna have to estimate, but I have to keep these equal. Oh, those were my Y coordinates. Let's try that again. Well, actually, let's just use it. Who cares? 3, 6, 9, 12, 15. This is X, this is Y. I probably wouldn't have counted by 3s on X. I probably would have actually counted by 1s or 2s, but it's already on there, so guess what? Miss Mary's just gonna leave it, okay? Our first point is 1 on X, 3 on Y. So kind of have to estimate where that is. So I'll write that in, 1, 3. The second one is 3 with 7. So 3, 7. And then 5 with 11. So 5, I'm gonna estimate is about right here. 11 is about right here. Probably have a little bit of human error. And 7 is my next point with 15. So about right there. So 7 with 15. Then I'm gonna connect. I should probably use a straight line. I'll use my beautiful plan book here to do that. I do have a little human error because my points aren't lining up perfectly, but that's okay, no big deal. And the important idea is this right here. It does not pass through the origin, so it is not in a proportional relationship, okay? 7. Use the table to write a proportion. Okay, there's a lot of different answers that you can write for these, so I'll just kind of go over a few of the possibilities. You need guiding words. Gallons to minutes. Monday, the ratio of gallons to minutes is 6 to 180, and Tuesday, it's 8 to M, and in a proportion, these ratios are equal. It can be as simple as that. You could put minutes across the top and gallons across the bottom so that both of these ratios are flip-flopped, okay? You might see it written on a test, on an end of course exam, where they actually put the units right in the proportion. 6 gallons, 180 minutes, 8 gallons, M minutes. That works too, okay? Both of them are right. We have the right numbers in the right spot, okay? Or again, these could be flip-flopped with both minute values at the top and both gallon values at the bottom, okay? Number 8, same idea. We need those guiding words. We're talking about classes and hours, and on Thursday, it's a 6 to 8 ratio, and on Friday, we don't know how many classes for 4 hours. So here's one possibility of what your proportion can look like. You can have the ratios flip-flopped as long as they're both flip-flopped, where you have your 8 and 4 on the top and the 6 and C on the bottom. You might see it written in a test or in a textbook where they put the units right in the proportion, like so. 4 hours, okay? And either one, either way of writing this would be accurate, okay? Number 9. Okay, all right, so x over 8 is equivalent to 9 over 4. And you can use cross products, you can use equivalent ratios. Here, well, 4 times 2 is 8. Do the same to the numerator. 9 times 2 is 18, which means x equals 18. Okay? And number 10. 17 over 3 is equal to y over 6. Okay, well, same idea. We can simply multiply by 2 to find that equivalent ratio. 3 times 2 is how we got to 6, so we have to do the same thing to 17 to find y. 17 times 2 is 34, so the value of y is 34, okay? Forgot what number we're going to. I did that on the last one. Okay, so it said we're going to 12, but now that I look at 11 and 12, those are finding the slope, which we are not doing. So we're gonna edit this. It's only going to be 1 to 10. Okay, all right, that's it, bye.